Hello, everyone. Welcome to ITS 450. Okay, so as you know, this week is a short week. Only today, we're meeting today. So today I'm going to kind of do a lecture and lab kind of thing. Just, do a lecture on some of the miscellaneous topics that we still have kind of left. And then after that, I'm going to leave it open in case you guys have any questions that you would have had during lab session on Thursday. You can ask any questions that you might have. I want to remind you again that we've got the end of the semester fast approaching. So you should be seeing the calendar right now. And if you look, today is the 24th, November 24th. So today we're going to cover some miscellaneous topics. Then we just have this week left, the week of the December 1st to the 3rd, where you can work on project. And then finally, presentations will be December 8th. Remember, you have to do your demo of your e-commerce site, which should include the testing and the way that you secured it and that you've addressed the challenges there. And then if for some reason some groups still want to present on December the 10th, they do have the chance. However, I encourage everyone to present on December the 8th. And then finally, you'll have your final exam, your written exam, during the week of finals. So basically, we have two things left at this. Well, three things, I guess. The CSRF lab is due. I've left it open, right? So as you know, I've left that open until the end of the semester. You can submit there. And then also you'll have your presentations and your report that's due on December 8th, as you can see here. And then finally, the written exam during finals week. I haven't checked yet, but I'm assuming it's probably going to be like that Tuesday, December the 15th. But you can always check just by going on Google and typing PNW final exam schedule, and that should give you the date of the exam. All right, so today, as I said, I'm going to do a short lecture, and then after that, I'm just going to leave it open lab. If you have any questions about anything, you can ask. So basically at this point, I'm not assigning any new labs, of course, and we've covered software assurance, right? So we covered the whole semester. We've really just looked at one single problem, which was really about, the labs of either web security or software security. So if you remember, we looked at buffer overflow and we looked at format string vulnerability. Right? We didn't look at all of these. We looked at the set UID as well, right? And we explored basically code injections on the C++ language to kind of exploit those. And then we switched gears to the web security side, and we saw same origin policy, SQL injections, cross-site scripting, and now we're looking at cross-site request forgery. So that basically gives you an idea of the basic essence here of software assurance. We're trying to secure our code for both quality and security. And, you have your project for that, but also you've seen a lot of examples of code injections with SQL, JavaScript, and shell code and C++. So that, those were the topics. The common theme was there's some vulnerability in the code. The solutions, as you have seen, are very simple. Usually they just involve input validation. All right, so today we're going to continue with that idea. I'm going to wrap up a few more. So we covered the web security main topics. And then there's just a few usually topics I leave towards the end that I'm not going to give you a lab on, but you can still, you might have some questions on the exam about them, etc. So there's two in particular that are really important, I think, because they're a little bit different or new. You know, a lot of these are similar, like, return to libc is a little bit similar to other things that we did. So that's why we didn't do all of them. But there's two that I do believe have some merit in kind of covering them a little bit. So the first one I'm going to cover today is this one, the Shellshock Vulnerability Lab. Let's take a look at that one. So you can, of course, take a read, in your book. This should be covered in chapter 3, right? So take a look at the book. Shellshock is there. As I said, we're not going to do the lab. However, I am going to use this as a source, this document as a source of what Shellshock is. And I'll just explain it, with the whiteboard and everything, kind of give you some intuition about it so that you have some understanding. But there's a reason why I think Shellshock is important, and that is that Shellshock is both, whereas before we've always focused on, let's say, like web security, the web, something related to web, JavaScript, or we looked at Bash, and we were looking at things in the command line and the terminal. As it turns out, Shellshock is one that combines both things. So Shellshock actually combines a web application, like a web server, and also Bash, right, the shell. And so that's why I think it's interesting. It's actually quite simple. It's not very complex, as most of these are, really. Most of these have always been very simple, really. And what's been difficult is creating the injection, right? The code injection, that has always been the challenge. But we're not really going to look at that much today. And in fact, with this Shellshock, there's no real attack. Even in this lab, it only shows how it works, basically. So let's talk a little bit about it. All right, so let's go over the overview first of all. So, but then, once we complete this, it should be obvious kind of what, how it works. All right, so the Shellshock obviously is called Shellshock attack because it relates to the shell, like the bash, CSH dash, right? Those command interpreters. And it's because it caused a shock, right? So it was a shock that something like this went undetected since 1989. So think about that, right? So that error was in that. So think about all the errors that currently are present in software, right? That apparently that error in the code was there since 1989. It was a very serious error, and it wasn't detected until 2014. All right, so the Shellshock, and as you know, and it happened with Bash, where Bash is actually, we've seen all semester, right, is extremely important for running scripts and everything. And you guys are, familiar with this because it's the same thing that in the set UID labs and all those labs where you had to like break the link to Bash and connect it to CSH and back to Bash again. So that's the same idea. We have a Bash, and up until 2014, September, the Bash had a vulnerability. Obviously, now that vulnerability has been patched because the vulnerabilities are, with software, they're always very easy to patch. But that, it was more of a, it wasn't really an error in, like syntax or RAM or anything like that, buffer overflow. It was more of an error of logic. It's like one of those things where you just didn't think that could happen. So on September 24th, 2014, a severe vulnerability in Bash was identified. It was nicknamed Shellshock. And this vulnerability can exploit many systems and be launched either remotely or from a local machine. So in this lab, this talks about Shellshock, the Shellshock vulnerability. So I'll explain how it works and everything. So there's a lot of wordiness here. Okay. Anyway, the important topics of Shellshock are the Shellshock of this lab are the Shellshock itself. Then it talks about several concepts like environment variables, function definitions in Bash, and Apache and CGI programs. Right. So these are really the four main points that need to be addressed in order to understand this concept. All right. Because really, Shellshock is just the attack, but the attack involves Bash. It involves the way that values and values and parameters are sent from one program to another program, and that's usually done through the environment variables. It actually also has to do with the fact that Bash, you know that it's a command interpreter. So in fact, Bash can run commands. You can also create functions and load them in Bash, right? So that's another thing that you can do. You can create a function, load it in Bash, and then Bash will take those functions and interpret them. So it's got, so basically the problem is really there. In the Bash used to have this code that it would take a function that was provided, it would parse it, and it would execute it, okay? And so it was not known that this could result in an error, but that was the issue. And then the way that the attack was implemented, which was through Apache and CGI programs. So we'll talk a little bit about that. So CGI programs are just scripts that you have available in your web server. So whenever you have a web server, you could have these scripts, and sometimes these scripts run every so often. And when you run the scripts, they run on the terminal, and they generate some data, maybe for the website, etc. And so you end up with these programs as well. Okay, so that's really the lab itself. Okay, so the first thing is that you need a Bash program that has the vulnerability. All right, so let's assume it's 2014, so the Bash program would have the vulnerability. And you can see here then, we can create a CGI program. Many web servers enable CGI, which is a standard method used to generate dynamic content on web pages, right, and web applications. Many CGI programs are written using shell scripts, right? Some people use Python, Perl. This is just a particular error for Bash. Therefore, before a CGI program is executed, right, before you execute the CGI program that you've written, a shell program will be invoked first, right? So that's the issue, that you're bringing up Bash. And such an invocation is triggered by a user from a remote computer. If the shell program is a vulnerable program, we can exploit the Shellshock vulnerability to gain privileges on the server. So here's an example of what a CGI looks like. So this is a very simple CGI. It's called myprog CGI. And the extension just means that it's a program that you have in the website itself. Sorry, in the web server itself. Okay, so that's what you have there. Okay, so all right, and so usually the CGI stands for Common Gateway Interface, but they're basically just little scripts that you have available for, as I said, to generate whatever dynamic content you might need. Which it's valid that you might you could argue you're doing some analysis, crunching some numbers with the CGI script, and then you're going to use that in your website as dynamic content. The problem is, though, that whenever you have a website or you have a script that could be run through the URL, you're basically accessing via the web the shell of your server, and that should make you really nervous because especially after you've seen everything that has happened, we've seen in this class, all the labs, you know that can be dangerous. And here the Shellshock vulnerability kind of shows that. So basically this CGI is a very simple one. It simply prints out hello world. So you can see here it's got, you know, the shebang, which basically says to use the bash, use bash, right? Find bash, and then run this code, which is, as you know, bash shell. So echo, you have a whole bunch of echoes, and then you echo hello world. All right, so that's really the idea. Obviously, this has to have the appropriate permissions, etc. So if you want to run a CGI, you can see here, you can easily just go to HTTP localhost CGI bin my prod. So CGIs, again, which are the Common Gateway Interface, are basically programs that you can have available through the web to run on your content, okay? Such as this one. You can also use curl, C-U-R-L, which you're using in your term project. But basically the idea is this. You have now these programs. Now this could also in theory be done also from PHP. There's a few, PHP has a few limitations on it. So we will look at that later at the end of the lecture today. But right now, let's just start with actual shell scripts. Right, so imagine this is a shell script. It's sitting in your web server in the CGI bin, right? You have it in there in the directory that's available on your computer. Somebody then runs this CGI, and the first thing it's going to do, it's going to try to find the interpreter. So it means it's going to bring up the bash or the terminal, right? And now it's going to try to run these commands on it. So here, obviously, nothing would happen because there's no all the. However, as you probably know, what's the danger with this? The danger would be if the user can provide inputs, right? So if the user provides inputs and those inputs somehow make it as part of the shell. Now, you might say, well, that's very difficult because how is the user going to insert another command into this text file, right? And you'd be right. That's definitely a challenge. However, if this shell script that's in the text file gets read from this file and becomes maybe a variable, data in a variable, and then that data in a variable gets interpreted by bash, then you might have a different situation. Okay, so that's really where this comes in. And in particular, that's where you need the environment variables come in. Okay, so passing data to bash via environment variables. Right, so to exploit a Shellshock vulnerability in a bash-based CGI program, attackers need to pass their data to the vulnerable bash program because they can't just modify the text file, right, or the file. So instead, attackers need to pass their data to the vulnerable bash program. And the data needs to be passed via an environment variable. So environment variables are whenever you have a process in memory, that process is associated with environment variables, right? And we learn, when we learn, for instance, from the SetUID labs and all of those labs, we learned that, sometimes when we entered code into a process, we would try to spawn another process, right? And basically what would happen is we would try to copy the permissions, like the effective ID of the original process onto the new process. Well, sort of the same thing is happening here. The environment variables that are in the original process get spawned into a new process, okay? And that's where the problem comes in, because you're gonna try to put your data into these environment variables, the code that you're supplying, and then you're gonna hope that that code gets executed, right? And that's where the vulnerability of bash comes in, that before 2014, it would allow for something like that to happen. So in this task, we need to see how we can achieve that goal. All right, so you can see that here. Here is the bash again. We have a few echoes, but now this bash, all bash will have an associated environment variable, right? And you can see that here. So this process has an environment variable. You can see that it's in proc and then environ, that's the variables. And so this basically here, when we run this script, this is just a demo that we can actually print out the contents of the environment variable. So line 1 here, right, prints out the contents of all environment variables in the current process. And you can see that there. Remember, these are as the process is running in memory. All right, and so that's basically another mechanism that's important. All right, so now, so these are some of the main concepts. So now let's think a little bit about how this would work. Okay, so let's go to everything else we don't need anymore. So let's switch over to the whiteboard, and let's talk a little bit about Shellshock. All right, so we have the Shellshock problem, right? And we've seen there's a few things, environment variables, there's bash itself, and so on. So at the end of the day, what we have is we have a program which could be a .cgi, could also in theory be PHP, right? We know that either the CGI is an actual bash program, which means that, you know, here you tell it to use bash, which means it invokes bash, or the PHP, if this is CGI, or if this is PHP, we know already that there's the system call. And the system call will also call bash. In either case, both of these call the bash program. So now we bring up the process in memory, bash. And remember, this is just going to be, in Linux, it's just the symbolic link, whatever it's pointing to, where it's CSH, bash, or dash. So that's the first thing. Now, the second thing is that we need to provide some data. We need to provide some data, right? So the user, through the web application, right, provides some parameters into this. Then these parameters, the trick is that you need to make these parameters, you need to pass them to environment variables, right? So you need to find a way for these to be passed to environment variables. So here, for instance, with PHP, that would be a challenge, because usually the system call does not directly pass environment variables. And so, but there could be a situation where a user enters data that is important, just some kind of data that you never thought that would be a problem, and then you passed it to the environment variables. Okay, you passed it to the environment variables of this process. When you made the system call, you spawn a new bash, and guess what? These environment variables also get passed to it. So now, basically, we have established that whatever you provided, let's say you provided here example, and that example got written to the environment variable, right? And then it's going to end up over here. Okay, it's going to end up over there. And that's where the problem comes in. The problem comes in that the next thing that needs to happen is that bash now will need to process its environment variables. And that's usually a standard process, right? It would just process whatever's in those environment variables and do something with them, right? So if it's got environment variables, it needs to, it's for a reason, because it's going to use them for some purpose. And the vulnerability here is the following. Bash would take any of its environment variables and assess what they were. So the vulnerability that existed in Shellshock is that bash would take you know, whatever the, let's say this is the input, right? The environment variable. And it would run it through some code. And the code would assess, is this a function or is this just like data? All right, so it would determine, is this a function or is this just data? And it really didn't think that someone could inject anything. It wasn't really thinking about that. It really just wanted to know, is this data or is this a function? That was the vulnerability that was in Bash for a very long time. And so what happened is that clever people figured out, okay, if I insert example, that doesn't do anything. But if I insert something like example ls-l, which is a command in Linux, that information gets passed, you know, into the environment variable, which gets spawned with, you know, into a new process, right? And after it gets spawned into a new process, Bash would check all of its environment variables, would try to assess if something was a function or data, and if it determined that it was a function, it would actually execute it, because it was because the last piece of the puzzle is that Bash actually is made in a way that it can process functions. So you can actually load a function into Bash. You can just say something like, you know, function f, and then the function just does echo, you know, hello, right? Some simple function like that. And you called it f, and then, you know, through Bash, then you can say something like, you know, I forget the key term, but it's something like load f, and that basically means now the function is there. So the function you just defined here, now you just load it here, and then you can, again, I don't remember the command, but then you could say something like run f, and when you run f, it echoes hello, right? So it echoes the hello there. And so that's really, Bash has that capability. So that's why, in a sense, it has this ability to check its environment variables to see if something is a function or data. Well, the attackers then exploited this idea that if they could, obviously they can craft something as an input and then send it into the code. They know that, for instance, as I said, in PHP, you get a system call, and then that generates a new Bash where the environment variables get copied. So the trick is, so it's not really, none of that is difficult. Once you have the Bash running and you have the data in your environment variable, then the code is probably going to check its environment variables at some point for some task. And that's where the problem comes in, because then the vulnerable code was the one that checked the environment variables to define if something was a function or data. And as I just, you know, based on what I just explained, if it found something to be a function, it would actually just run it, right? There was no check, no input validation, no, you know, was this supplied by a user? None of that. It would just do it. And so, you know, astonishingly, that vulnerability stayed in there for a very, very long time. Obviously, that has been patched now, so that wouldn't work anymore. But, you know, it's been there. Now, the challenge, though, that, you know, everything, as you know, you can have a system call here. We can establish that this creates Bash. Bash had the vulnerability. Bash is going to read its environment variables. Bash can run functions. The one thing that made this really hard, though, was the fact that the user needed to somehow overwrite or add information into the environment variables, right? So that's really the tricky part, okay? So in a PHP program, this is less likely to happen because you would, the program that you wrote, not only does it have to have a system call, but it would also have to have a update environment variables call, and that's very rare in a PHP program. That in itself should be like a red flag. You probably shouldn't be doing that, but you know, that makes it difficult. And so in the CGIs, that was because it's Bash, that was a little bit easier to do, but in both types of attacks, in both types of problems, that is really the hardest part of the attack. Okay, that's the hardest part of the attack. So now again, so in summary, Shellshock. In summary, Shellshock is an attack There you go. So Shellshock is an attack that involves both, .cgis or .php files. So that would be, sort of like web security, but where both of these try to access bash. Okay, the shell or the terminal. Okay, because as I said, with a system call or directly, as you saw with the shebang, right, the command that calls bash. Right, so that should be very clear and very well established. When you do this, whatever environment variables you have here, environment variables, right? Environment variables, this is a process. When you do a system call, you spawn a new process. So therefore, you can copy the environment variables, just like in the past. We knew that we could copy the effective ID of a user, for instance. Right, so once that's established, what happens is you can expect bash to check its environment variables. Depending on whatever the logic is, it would check the environment variables, and that was the problem, that the attacker just needed to craft, so like I had said, hello, or sorry, echo hello. Echo hello, right? So echo hello, but then, provide some kind of a command, ls-l, or something even worse, right? And then when the bash was parsing its environment variables, if it found something like that, because of the logic of how it is, that bash can process functions, it would take whatever's in the environment variables and quite simply just, it has a function called parse and execute. So it literally just parses it, and it's going to say, is this data or a function? And if it's a function, it just ran it, right? And so that was really the vulnerability. So the challenge again was getting the data into the environment variables. However, as I said, there are some environment variables there. So that's the last piece of the puzzle, how to understand that a little bit more. So let's look a little bit at the environment variables. So in the CGI, for instance, in the .cgi, you would have, let's say, the script, bash, and then, echo, whatever. So you can imagine that if a browser calls this script, right, there's information about that browser that is always helpful, right? So for instance, you want to say, was this initialized by Mozilla Firefox? So there's basically the metadata. The metadata of who initiated the CGI call, because it's sort of a web-based application, right? Just like whenever you call a web page, the web page is called by a browser, and the browser then, you guys know that when you send that GET request, there's a lot of data associated with that GET request, right? So think of it this way. So if I have a browser, right, and in my browser, I open, my URL, some page, whenever I hit that button, etc., as we've seen, you generate a GET request. And we have seen from live HTTP headers that there's actually sort of like the data, but there's also a lot of metadata. Right? There's a lot of metadata associated with it, like, the referrer, and, let's just take one thing, what browser initialized the communication, right? So in this case, Mozilla. So as it turns out, a lot of the time, the environment variables associated with a CGI, with the .cgi file, the environment variables can capture that metadata. So that when you run this, right, when you run this CGI from wherever your browser, the data about the originator, sort of Mozilla, would get into the environment variable. You see that? And now you found a way to associate this CGI with some metadata. And so the final question is then, is this something that you could control as a user? So as an attacker, as a user, is this information about, for instance, the origin of who called the CGI, right? That metadata. Is that something that you could control as a user? And as it turns out, you've probably seen that you can control all of this because that's what you're doing in the cross-site scripting lab and also in the CSRF labs, right? In both of those labs, you have seen that you can easily craft GET request, POST request, and you can change all the parameters. So it turns out that you can also do that here. The user can easily just, instead of saying Mozilla, they could say probably Mozilla ls-l. You see that? And by doing that, then, as the metadata of the browser actually gets into the environment variable, which gets associated with this CGI process, so they both become a process in memory, .cgi bash, and also its environment variables, which, by the way, contain that nefarious ls-l. So now when we go back over here to the, here, right, now the environment variable is there. The browser, Mozilla information, ls-l, has gotten in there as well. It gets into the environment variable. And now the associated environment variable and bash have the information. Again, the code here then will most likely check its environment variables for some reason. And when it does that, it's going to find this in the metadata, in the environment variable. And now the problem is it had a vulnerability that it would, it would get any input, check if it was a function or data, and if it was code, it would just run it, because bash is made to run functions basically, and that's it. So those are all the elements. As I said, there's no lab for this today, although you can do this lab if you'd like. But this is the idea of the Shellshock vulnerability. Okay. Are there any questions about this, guys? Did it make sense?
It makes sense.
Makes sense? All right. Okay, so if you want to read more about it, what I would recommend is that, as I said, that we're out of time, and I really don't want to give you any more assignments so that you can focus just on the project. But if you want to read more about it, you can go to chapter 3 in your book, and pretty much all of it is explained there, pretty much what I just said. You can read there, section 3.1 will talk about shell functions. So section 3.1 will talk about what I just said about, this part here, about the functions and how bash is really made for that. And then, how to run them. And then environment variables will follow in that same section. And that's just, where you store the data for a process, basically. And then it'll talk in section 3.2 about the Shellshock vulnerability itself, the bug, which, like I said, it was just the code would just run things. You know, the actual code is in section 3.2.3, the mistake in the bash source, okay? Right, so it'll show there. So the problem is, you know, bash checks its environment variables for exported functions. So it literally says here in this code, line 1, bash checks if there is an exported function by checking whether the value of an environment variable starts with, you know, parentheses or curly brackets. So think about that. That was the logic. So if it was just looking at the input to see if it started with, you know, parentheses, curly brackets or not, that just gives an opportunity to any attacker to say, well, you know, I just need to put parentheses and then it'll be run, right? So that was really the problem. Once a match was found, bash would change whatever the environment variable value was to either data or a function. So it would just do it for you. And so that's what the attackers needed to figure out. It's like, if that was there, oh, it's a function and it, you know, it's just going to do it, for instance. All right. So anyway, take a look at that one. It's a pretty straightforward, I think, lab or problem. Okay. And then we talked a little, now the other thing that we talked about was, I think CGIs, that should be pretty straightforward. What you might want to read is section 342, how the web server invokes a CGI programs, right? Which, you know, it'll be through a URL or curl. And then basically, once you run the CGI either through a web browser or through a curl, basically, as I said, you know, remember this idea that when you run a web page from a browser, there's metadata associated with it, right? That goes into GET request, like, you know, what was the user agent, HTTP host, all of those parameters. Well, as it turns out, all of those parameters can be set manually, and that's what I, you know, what I explained over here, where I said, you know, you have the CGI. If you run it with curl or you run it with a browser, well, as it turns out, we know that this generates a GET request, and GET requests not only have data but metadata, such as the Mozilla. So the trick is, can that data be modified? And yes, it can. And by the way, that data conveniently would go into the environment variables of that CGI. So you have all the pieces of the puzzle together. All right. All right. So are there any questions? That's pretty much all I have for this one. As I said, I'm only doing, you know, a few miscellaneous topics today. I have another one. So are there any questions on this one?
Nope.
All right. All right. Please, you know, if you have any questions, like I said today, it's kind of a lecture lab. So maybe you can ask questions later if you have them. I'll be happy to go over it again. All right. Otherwise, if you feel that you understood this one clearly enough, it will be on the exam, so you can expect a question on this one. Let's look at another one. Another one that I think of all these software or web security that, you know, remember, there might be 10 of them. We don't need to do all 10 because some of them are very similar to other ones. But these are the ones that I usually leave at the end of the semester, because I still want to cover, because I think that they are different enough that they merit some attention, right? So this one, Shellshock, is one of them. The other one is something called the race condition lab. And so I have some slides for that. So let me bring that up, please. All right, so let's bring up this other one. I think I have some slides here. And like I said, I'm going to explain this basically similar way. There is a PDF. I'll point that out. If you want to read through it on the Seed Labs, you can certainly do that. All right, so all right, so first, before I go to the slides, let me just share the, show you where it is. All right, so you should be seeing now the Seed Labs website, and if you go to the Seed Labs, there's another lab here, I think under software security. This one is also it's a different one. It's called the Race Condition Lab. And I find it to be very interesting, and I'll give you a little analogy of what I have. But you can take a look at it. The Race Condition Vulnerability Lab. All right. This one talks about a resource like in the file system, basically. Okay. And so you can take a look at it there. And I recommend read it. It should be a very interesting read. I'll just kind of summarize it though in my slides here and what I think about it. All right, so you should be slides now. All right. So this one is also file input output. That kind of it relates to that. It relates to concurrency. So one way of talking about this, the file input output. So this is different, right? Because this is technically, it's technically an injection as well, I guess, but it's a little bit different, right? So it relates with a resource, which in this case would be a file, okay? A file in the file system. And that file in the file system is something that two processes want to access. Let's say there's a file. And then there's this process, and then there's that process, and then there's an attacker. So these are okay, process 1, process 2, but then there's an attacker. So what happens is that, let's say that the processes haven't accessed this, then comes process 1, and it checks the file, and it checks it and it says, oh yeah, everything's okay. It did some check to make sure everything was okay. But then as it was about to do the second thing, it became distracted with another process. While it got distracted, the attacker comes in, is going to access the file, make a change to it, let it go, and then after making the change, the process again makes an access. And during that time window, which is called the race condition, the file has been modified, but the process really doesn't know. So it did an initial check at time 1, right? And then another check at time 2. Between time 1 and time 2, well, let's say time 3 actually. Time 3, the attacker does something at time 2. You see that? They make a modification of the file. So really, this one's a little bit different because it's an external, what's happening here is happening really to the external file. So this has to do with the idea of concurrency, right? These processes, the attacker and the P1 and P2, there are 3 processes that are running on the operating system concurrently at the same time. So in a sense, they're racing against each other, right, to finish first. And so that's where the problem can come in. All right. Any questions so far? So that's the general idea of the race condition, okay? So at the heart of this is a concept called concurrency, and I'm sure you've seen this already when you took your operating systems class with Professor Tu. I'm sure you guys talked a little bit about concurrency there. All right, so concurrency occurs, the definition of it, let's say, is that concurrency occurs when two or more separate execution flows are able to run simultaneously, right? So that's what I just explained. Examples of independent execution flows includes threads, processes, etc. That we know, an operating system has multiple processes running in the background. So concurrent execution of multiple flows of execution is an essential part of a modern operating system. Okay. So the race condition then is the topic that we are studying right now. It has to do with a vulnerability it has to do with an exploit, rather, that is going to try to take advantage of this vulnerability, right? So race conditions is an unanticipated execution ordering of concurrent flows that results in undesired behavior. And this can be a lot of things, right? This can be a lot of things. So I'll give you an example of one of them in a second, but that results in undesired behavior and is called a race condition. It's a software defect and frequent source of vulnerabilities. So I'm sure, we've done a lot of software assurance issues that we've explored in this semester, but you probably hadn't thought of this as well, right? So now you're telling me, you're probably thinking to yourself, now you're telling me that I have to worry that when I have a process, if I take too long between one step and the next, someone in between there could affect my code. And yeah, that's what this is saying anyway. So race conditions result from runtime environments, including operating systems that must control access to shared resources, especially through process scheduling and so on. Okay, so usually there's some kind of a file in there. So a race condition would need concurrency. There must be at least two control flows executing concurrently. A shared object is the race object, okay? A shared race object that must be accessed by both the concurrent flows. And in this case is the, let's say, the good flow and the bad flow, right? So the attacker is one process, and then there's the process that genuinely needs to access the file. So this is the process, good process needs to get access to that file, but it's gonna make multiple accesses to the file probably. And so while it's doing that, the attacker will try to do something bad to the file, and you guys will see an example of that. And a change state, at least one of the control flows must alter the state of the race object. So that, in this case, the attacker is going to change the state to take advantage of something, right? So we're going to look at the example of stealing passwords, for instance, or actually not stealing, but creating some information, adding some information to a file. So, if you've ever seen the movie from the 90s, The Matrix, that movie, although it was, like fantasy or sci-fi, it was really about computers, right? So basically the Matrix was the simulation. So if you think about it, the Matrix was exploiting, at least, some people believe, I believe that what they were saying was that Neo there in that movie had figured out how to exploit race conditions in the code. All right, so what Neo had figured out, and also the agents. So everybody that was able to, because the agents could do this as well, right? They were faster than things, and so what they had figured out was that Neo was really like trying to change a file, right? So if a file has a state, they would change the file and then they would alter the reality of things, right? So that's basically one way that you can try to explain how they were able to do those things in the matrix, right? It was through that mechanism. So the matrix basically had a race condition vulnerability. All right, so eliminating race condition. So basically the idea with this is that in a race condition, you have race windows. Okay, you have race windows. So a race window is a code segment. So a race condition means that a code segment accesses the race object in a way that opens a window of opportunity during which concurrent flows could race in and alter the object. Okay, so you alter the physics of the object or whatever it is so that, you modify it basically. So you had an object, you were expecting it to be like this, somebody comes in, changes it. When you access it again, it has been changed, right? So basically you have to eliminate race conditions by making conflicting race windows, basically deleting them or not having them present there. All right, so the best way to understand this is let's take a look at some code. So we're gonna look for that race window, which is called the time of check to time of use. All right, so and that basically implies that you check the file and then you use that file. But the period between check and use is the period that causes the race window. Okay, and we can see that here, I believe. So we have, all right, so here we have it. Although it seems trivial, here it is. You have basically a file, right, Ph.D. Notice that we have a statement here, if access some file, okay, right? So you check the file. Whatever the file is, you came in and you checked it. Then, guess what? You don't use the file, but instead take let's say this is step 1. And then this in step 2, you don't do anything with the file, but instead what you do is you print out a statement or you do something else. And then in the third step, you do fopen some file. So now you once again go back to the file. So the problem is that has created this idea of time of check, time of use, where it means that although it seems very small, you have in here between the check and the use, you have created what is the race window basically. And during that period, the attacker then could come in, modify the file, and then now it's not the file that you intended, right? So you can see that here. So first, the access function is called to check if the file exists and has the right permission. Then the file is open for writing, right? That's in the third. So this is 1, 3. But in the, oh, it keeps erasing these. But in step 4, right, this would be 2. And so not 4. In step 2, in there's a race window between checking for access and opening the file. Okay, and that is the problem there, right? That's this type of a vulnerability called, the race condition. So now let's look a little bit more concretely at an example of this. All right, so let's imagine an example where you have a file and there's another file, right? The attacker wants to append something at the end of this file. right? You have a process over here that is setUID, right? It's a process, it's a nice process, process one. It gets some input from another file. This is the input file. And all that the process wants to do is it wants to read from here, and then it writes that content into this file, right? So it'll add it at the end here. What the attacker wants to do is the attacker wants you to write to that file. Okay, let's just worry about that for now. So what does the attacker have to do? Well, the attacker knows that you're going to check the file first. So you're going to check the file for whatever reason. You check it. And so the attacker is going to let you do the check. But between you checking and you writing to the file, it's going to take advantage of that opportunity to do some change. So one thing that could happen is the following. Let's say that process one is it's accessing a file. But remember that in Linux, we can have files that are actually symbolic links to something else. So let's say this is symbolic link, and this is file real, right? So just to put this more concretely, the attacker, what it could do is, P1 checks the file, everything's okay, then it gets distracted for a millisecond, and during that millisecond, this is FR, by the way, and this is F, let's say, $ for money, right? Wants to steal some money. So in that period where after you check, but before you write to the file, the attacker comes in, deletes the symbolic link, and creates a symbolic link to another file. And so what's going to happen now is you still write to FR, or sorry, this should be, no, you're writing to FS. FS originally was pointing there, but the attacker removes the symbolic link, and now it points to $. You see that? And so basically, you end up taking the contents of this file, right, and writing them here. So you actually force the program to do that, and that's what is called a race condition. All right, so it's a different type of attack because it's not necessarily an input. At no time, excuse me, at no time, it's not an injection, right? Attacker, everything that we've seen all semester, and hopefully this is obvious, even what we just saw now with the CGI, we were injecting that code, right? Everything we've seen all semester, we would inject code into P1. This time around with the race condition, we did not inject anything into P1. Instead, we took advantage of the fact that P1 is trying to write to F, but we try, there's a third element here, which is the symbolic link. The symbolic link and FR. So process is trying to write to FR, but it does it through a symbolic link. So attacker comes in, never does attacker inject anything into P1. It just removes that symbolic link, which means it has to have permission to do that, right? Which it might happen. The attacker may not have any access to P1, right? But it might have access to change the symbolic link to FR. And so it changes that symbolic link so that it now points to $, and now P1 will end up writing to $, instead of FR. And that's the race condition. But what's important about it is this idea, right? That the program will in fact check the file. But between checking and writing, there could be additional code. There could be additional steps that it takes. And that period of time, that tiny time window gives an opportunity for the code to be, for the, not the code, but the flow of the code to be modified. And that is the idea behind a race condition. What do you guys think? Does this make sense to you? Are there any questions?
Yeah, it makes sense.
No questions?
Yeah, it makes sense to me.
All right. So what would be the solution then? What do you guys think? What would be the solution to this? In the code, just don't overthink it. In the code, what would make sense for you to do?
Would it be to move open to right after when you check it? It's like
Say that again.
like move open to right after the check, so like don't have the print statement or put the print statement somewhere else.
So reducing the size of the time window, definitely, right? Because that's and again, you touched on something very important, right? And that, that's why I was, Neo there, right? You have to be really fast in order to be successful, right? And Neo, if you guys look, Neo learned to be faster and faster and faster in the Matrix, right? I don't know if you remember. You probably think I'm crazy talking about this, but if you remember in the Matrix, Neo at first was, at the speed of the agents, but then over time he just became faster and faster. He saw everything in green and everything, but
Because he believed.
Right? Right? What was that? All right, I didn't catch that. What did you say?
I said that Neo began to believe. That was like the whole.
Well, but it wasn't a religious thing. It was a technical thing, right? It was the Matrix had a vulnerability. Anyway, that's the way I interpret it. So the idea, anyway, but you touched on a very valid point that you want to be really fast, right? As Joey said, if you make this time window bigger, right? What do you have now? Instead of having nanoseconds, you might have, a little bit more time, right? Because you have to be really fast in changing that parameter. So yes, exactly. That's one thing, reducing it. Another one is, and you can see here in the code itself, and this just talks, you can read through the slides. Basically what I explained is there. But the other thing that you can do is that you can have a check after, basically. Okay, so that's really the idea. So you want to check that the file hasn't been modified, kind of like this. You do an LSTAT before and an LSTAT after. You guys know what I mean? So it's like here, right? So you don't just do this, but you actually take the status of the file and you save that. Then you process the file, you do everything that you did, and then at the end, you do another else status. Because now, the race condition, then the attacker would also have to be really fast after this to set it back. And so that decreases the chances of you not detecting it. Do you know what I mean? So LSTAT, do whatever you want, access the file again, do whatever you want, LSTAT again. And that way you check that the status of the file never changed and therefore there was no race condition. Make sense, guys?
Yep.
Yeah, all right. Well, that's it. So that's that. As I said today, I was just gonna do some miscellaneous topics that I have that I've been looking at in your book that are a little bit different from everything else that we've done, and hopefully these two their labs, but you know, we're just really out of time for the semester. And as I said, I don't want to give you any more. These would be 2 additional labs that I just don't want to burden you with if you have the project. So I've explained race condition. Hopefully that makes sense. I've explained the Shellshock. Hopefully that made sense. Both of those will be on the exam. You can also read the chapters in the book. Okay. I'll be posting this video later today. And so that's pretty much it for new content today. Given that this is a short week, I'm also going to, the rest of the time, I'm just going to leave it as an open lab. So if you have any questions about anything, please ask. I'll be here until the end of class, or the project, or anything, you know, anything else you might want to talk about. All right. So you can stay definitely if you have any questions, work on your lab. Otherwise, I'm going to pause the recording.